Okay, everybody, this is chapter 3, section 4. This is dealing with parallel and perpendicular lines. So just a really quick review. Parallel lines are two lines that are on the same plane that will never intersect. And then perpendicular lines are lines that will intersect at a right angle. Okay, so there's three theorems here. I don't want you to get hung up on the numbers here. Really, they're just, we have set them up, or the book actually set them up as theorems that are in chapter 3, and they were number 8, 9, 10 that we've covered basically. So I really just need you to know the theorem and the definition of it, okay? And I'm going to draw some pictures off to the side. So if you want to write these down really quick, and then I'll kind of illustrate them. You could hit pause always, when you get maybe behind a little bit of notes, because I go kind of fast on the video. So, hit pause, write down your notes, get caught up, and then hit play and kind of group back with us, okay? First one says if two lines are parallel to the same line and they're parallel to each other. Okay, so let's just go ahead and draw lines A and B. Okay, but it says if two lines are parallel to the same line, then they're parallel to each other. So I think that tells me I have to have a third line. Okay, so if I say that A is parallel to C and B is parallel to C, so that's kind of what the if part is in the theorem. If two lines are parallel to the same line, then the two lines are parallel to each other, okay? So that's kind of what that one's saying. It's kind of, if you want to think of it, it's like a transitive property of some sort. So you can't say that, but it's kind of like it's a transitive property, that we kind of know already, right? All right, the next one, in a plane if two lines are perpendicular to the same line, then they're parallel to each other. So let's go ahead and draw that. All right, so if I have, A and B, can't draw the letter and the line at the same time. Hold on. Okay, I have lines A and B, and then I have a line C, and if both A and B are perpendicular to C, then they'd have to be parallel to each other. Okay, and that kind of, if you think of a transversal, okay, you think of the transversal being line C, and it's intersecting A and B at a right angle. Well, these two angles that are both 90 are equal to each other, and in a transversal, those would be corresponding angles. And we learned if corresponding angles are congruent, then the lines are parallel. So in this case, A and B would be parallel. Okay. All right. In a plane of two lines, this is the last one. In a plane, if two lines are perpendicular to one of two parallel lines, then it's perpendicular to the other. So let's go ahead and draw line A and line B. And line C. And a line D. Okay. Okay, so this one gets kind of confusing. Let me make this a little bit bigger here too. In a plane, if two lines are perpendicular to one of two parallel lines, so we could kind of play here. I'm going to call C and D my parallel lines. And if A and B are perpendicular to one of them, so let's say it's perpendicular to C, okay? If they're perpendicular to C, then it has to be perpendicular to the other line, in this case, D. Okay? So a lot of stuff going on there. I got two lines that are perpendicular to one of two parallel lines. So I said C and D were parallel. A and B were perpendicular to C. By rule, they have to be perpendicular to D also. Okay? And if you look at that, I got a couple transversals there. The transversals have angles that are congruent, and those congruent angles are corresponding. That would show that they're parallel to each other, and then perpendicular, it's already been defined. Okay? All right. So let's go ahead and take a look at these. If you guys could go ahead and draw, let's just do A and B really quick first. We want to solve for x. We want to use some rules here. We have to identify that this angle is an expression, but this angle right here is 90. We have to be able to see here that, hey, I think I got vertical angles, and I know that vertical angles have to be equal, so I can set them equal to each other. So I can take this first one, it's x squared plus 9, and I can set it equal to the angle that it's vertical to. Well, the angle it's vertical to is right, but it also has a value of 90 degrees, okay? So I can use some rules here to set up an algebraic expression to be able to solve for my variables. So I'm going to subtract 9 from both sides. I get 81. To get x by itself here, I'd want to take the square root of both sides, and I get 9. So if I plug 9 for x, I get that x squared is 81. Plus 9 gives me 90. Both the angles are supposed to be equal, and they're both 90. Okay. Same kind of situation here. I've actually got these two angles. They're vertical again with this right angle. So I can take two angles and I can actually add them together. So the x angle and the 62 degrees would be equal to 90. And then I can go ahead and subtract 62 from both sides, and I get x is 28. So these are kind of test question type of problems there. Really want to make sure that that we're able to identify what vertical angles are, know the definition, and then be able to set up an equation. That's a big thing, set them up and be able to solve it. Okay, so you got to know your rules. You got to be able to take those rules and apply it to an equation. Okay. Okay. On this question, this is kind of a tough one, and since we're doing it on a video, I'm just kind of really going to go after it right off the bat. In class, I try to get kids to talk this one out and be able to figure it out and throw out some clues and whatever. But I have two different lines, and we know that a line is 180 degrees, both of them, and they're separate. Okay, and angle or lines can be broken up into different angles, but the key here is that both of them are equal to 180. Okay, and I can set up an equation for both, so I'm going to go ahead and do that. I'm going to take the two angles for this line. I'm going to add them together, and it equals 180. I'm going to take these two. Actually, there's three angles. There's 1, 2, and 3. And there's two ways I could do this, but I'm just going to go ahead and take each angle and add them together and equal 180. Okay. All right. So, what they're asking me to do here is to solve for x and solve for y. Well, I got two different variables. I can't really solve them, get a value for x, get a value for y. But in Algebra 1, we learned about systems of equations where I can take two equations that have the same variables and use elimination to solve it, okay? But first off, to do that, I have to get x and y, in this case in both equations, by itself. So I have to, in this one, I have to get rid of the 10. So I'm going to have to subtract it to both sides. And I get 5x plus 2y is equal to 170. Okay. I'm going to have to come over here to the other equation and kind of do the same thing. Now I got a negative 10 and a negative 20 and a positive 90. In my head, I'm going to get that 60. So I'm going to get this. And then I'm going to have to get rid of the 60 by subtraction. So I'm going to subtract 60 both sides. And I get that. Okay. Make sure I did that one right before we move on here. Okay, so we're good there. All right. So now, if you guys, in your Algebra 1 classes, if you learn systems, we're going to take these and we're going to use elimination because it's kind of set up for that. There's other stuff we could do in systems, but we're going to kind of stick with this, okay? In elimination, what I want to do is, one nice thing about elimination is you kind of have some control over this, and you can kind of decide what to do. First thing we want to do is decide, do you want to get rid of the x variable or the y variable, okay? And if you kind of remember, I have to do something to both equations to get the whatever variable I pick, the value or the coefficient of them, they have to be able to cancel each other out. So I have to make them the same value, and I have to make them different signs, okay? Because what I'm going to do is add these kind of vertically. So what I'm going to decide to do is multiply both equations, and I'm going to eliminate y. Okay. So what I'm trying to do is make both of these be the same value. So both 2 and 3 go into 6 evenly. So to get the 2 to be a 6, I have to multiply it by 3. And to get the 3 to be a 6, I have to multiply it by 2. But also my issue is that both of these are positive. So I have to make, one of these values out here, I'm going to have to make one of them negative. And you get to pick. It doesn't matter which one. I'm going to do the bottom one, okay? So let's change both of these, all right? So I'm really going to kind of like distribute these values all the way through, okay? Now you got to go all the way through all 3 parts. So 3 times 5x is 15x, 3 times 2y is 6y, and 3 times 170 is 510, right? Go to the second equation, I'm going to multiply by -2, so I get negative 6x minus 6y, negative 240. Okay. So elimination, you're eliminating a variable because I'm going to eventually make it 0. So let's see how that works. So I add each column vertically and rewrite it. So 15x minus 6x is 9x. 6y and negative 6y eliminate each other. And then 510 minus 240 is 270. Okay. And now I can solve it for x. So I'm going to go ahead and divide both sides by 9. And I'm going to get x equals 30. Okay. So once we get a value for x, we need to then, we're solving for both x and y. So I need to go back to the original equations, either here or here. And this is another nice thing about systems, in this case elimination, you get some control. Would I rather plug it into the equation on the left, or plug the 30 for x into the equation on the right? So to me, the equation on the left seems a lot more manageable to be able to do that, right? So it's 5x plus 10 plus 2y equals 180, okay? But we solve for x, so I'm going to substitute that in, and that will now allow me to solve for y. Okay, so I get 150 here. I'm substituting it in. 150 and 10 is 160. And then I want to subtract 160 from both sides. I'm going to go ahead, divide both sides by 2, and y is 10, okay? And if I take the value for x and the value for y, and I plug them in my original equations, I see that it works, okay? So that's just taking algebra and kind of aligning it with some geometric formula, theorem, whatever. You know, we just have to be aware of stuff like that. And typically I would kind of warn you, hey, you got this kind of strange problem here. You want to think this way and try to work it out with you, okay? We don't always think kind of outside the box a little bit on stuff, okay? All right. Kind of to end stuff, looking at a transversal, looking at parallel lines, looking at perpendicular lines. This is a door frame that you would typically have in any house, any room in the house, whatever. But you know, if you're a carpenter or a contractor, certain things you have to be aware of. You're going to install this molding that's going to go around the doorway, and I'm going to cut the top of each piece and one end of the side pieces at 45 degrees. And this isn't, you know, really well drawn picture, but you're cutting with a special saw each end piece at 45 degrees. Okay, so that means like when I take this corner and apply it to that corner, they're both of them are going to be 45 degrees. Well, what's 45 plus 45? Well, I think that's 90. So if I kind of look at, you know, when I do put it together, each piece was 45. Together they make 90-degree angles here at the corners, okay? So that's kind of important because it makes, first off, the door should be strong. You know, people say an earthquake, go stand in the doorway. It's supposed to be one of the stronger places in your house. But the question says, will the side pieces be parallel? Well, if you think, you know, if I extended lines here, I have a transversal, these two angles in a transversal are same side interior angles, and in a transversal, if the lines are parallel, those angles have to be supplementary. I know they're equal, but they have to be supplementary. And if they are, that would say that the sides, or the sides in this case, are parallel. So yes, they will be parallel. And we explained because the angles are same side, they're both 90, they add up to 180, they're going to work, okay? All right, that's it for today on that one. We'll go through section 5 in a different video. So if you have any questions on 3, 4, make sure you get a hold of it. Thanks.